So with lesson 3, we start in on a different type of transformation reflections. So there's a key term that is at the top of this page. It is one that you guys need to know. It will be asked on the diploma. You will get a question on the diploma saying, what is the invariant point of this transformation, or what is the invariant point after this happens? The invariant point is the point that doesn't change. So in a translation, there would never actually be invariant points because all the points actually move locations throughout the graph. Whereas with a reflection, and then when we look at stretches, there are invariant points. There are points that after I do the reflection, the point didn't actually move. It's the same as it was after that it was before. So if we compare the graphs of y equals f of x and y equals negative f of x, we have the graph of y equals f of x equals x squared minus 10x plus 25 is shown. And the question is, write an equation that represents y equals negative f of x. This negative applies to the entire equation because it's outside that bracket. It's not with the x's, it's actually with the y. So my equation would be y equals negative x squared minus 10x plus 25, which when I multiply everything inside the brackets by that negative 1, I would get negative x squared plus 10x minus 25. So what I would like you to do is grab your graphing calculators and sketch or graph both equations so that you can see the before and the after. And you can see what your grid setting should be. It's just on a normal 10 by 10. So when I graph this new function, I get a parabola that looks the same as this, only what's happened to it? It's been reflected. Instead of pointing up, it points down. Is there a point on this graph that didn't move? What point is that? 5 and 0. The point 5 and 0 stayed the same. It did not move as I did the transformation. Okay, so let's look at the second part. The graph of f of x equals x cubed minus 8 is shown. It says write an equation which equals y equals negative f of x. So that's multiplying this entire equation by a negative 1. So I would now get negative x cubed plus 8. Again, I'm going to give you a moment. I want you to graph this on your calculator and then sketch the two graphs, or sketch the second graph. So this time when I graph this function, I get a graph that looks something like that. Is there a point on the graph that did not move? 2 and 0. And how does my transformed graph compare to the original graph? So how could I take the graph in black and draw the graph in blue? Reflect it in the x-axis. Okay. So if I look at part 3, the graph of y equals f of x is shown. How would I sketch the graph of y equals negative f of x? What would we do? Okay, so how would you do that? Like, what would you...
I would pick points.
So give me a point that you would pick.
Negative 1 and 2.
And what would I do with that point?
Then it would be negative 1 and negative 2.
So I would reflect that point. Okay, what else would I do?
The points on the x-axis would stay the same.
points on the x-axis would stay the same. They would stay my invariant points. And then because I've got straight lines, to join a straight line, I just need the 2 points. Okay. The replacement that I have this time is I'm replacing y with a negative y. So when we did the translations, we were doing replacements, replacing y with a y minus k. When we do a reflection, we're replacing y with a negative y. And that causes a reflection in the x-axis because it's my y coordinates that are being changed. It's my y coordinates that are being reflected. So even though the reflection is in the x-axis, it's the y coordinate that was reflected. So if we look at the next page, now we look at the graphs of y equals f of x and the graph of y equals f of negative x. So right from there, what's my replacement? The x coordinates. I'm replacing x with a negative x. So this time when I have the same equation that I had for part 1 on the previous page, only now I'm replacing x with a negative x. So what I would get would be negative x squared minus 10 times negative x plus 25. So when I take negative x and I square it, what do I get? Positive x squared. And when I take negative 10 and multiply it by negative x, so now use your calculator to sketch both graphs. So when you went to sketch the second graph, what did you notice?
It's reflected through the y-axis.
It's reflected. So this 5 and 0 became negative 5 and 0. And then look like that. Can you find an invariant point on that graph? 0 and 25. Okay. You would have had to adjust your window settings so that you could see where it crossed that y-axis. So then if I look at part 2, if I rewrite this equation by replacing x with a negative x, I get negative x cubed minus 8. So what is negative x cubed? Negative x cubed. So let's see if we can sketch this without putting it on our calculator right away. What do we know is going to happen? Where's my reflection line?
Through the y-axis.
Through the y-axis. So what do I know about this point right here? It's going to stay the same. It's not going to move. And everything that's on the left-hand side is going to move to the right-hand side. And everything that was on the right-hand side will move to the left. And then this point here, which was 2 and 0, would become negative 2 and 0. So now use your calculator to check to see whether or not you did it correctly. So what's my invariant point this time?
0 and negative 8.
And how does the graph of y equals f of negative x compare to my graph of y equals f of x? It was a reflection in the, which axis?
Y.
In the y-axis. So my replacement this time was replacing x with a negative x. What do you notice about your invariant point? Which coordinate is 0? The x is. and when I take 0 and I multiply it by a negative, what happens to it? Stays the same. That's why the invariant point is along the y-axis, because my x-coordinates are 0, and when I multiply 0 by a number, it doesn't change the number. So previously, the invariant points on the previous page, the y-coordinate was always 0, and my replacement was replacing y with a negative y. So again, it doesn't move because there's no change when I apply that reflection or when I apply that transformation. So if I look at part 3, it says the graph of y equals f of x is shown. How would I draw the sketch, or how would I sketch the graph of y equals f of negative x? So what would I do this time? Where would my invariant point be?
At 0 and 1.
0 and 1. And then what would I do to draw the rest of the graph?
Reflect points through
Reflect points through which axis?
the y.
The y-axis. So if this point is 1 to the left, it's going to reflect 1 to the right. 0 and negative 3, or sorry, negative 3 and 0 becomes 3 and 0. 1 and 0 becomes negative 1 and 0. And there's my graph. So again, my replacement is I'm replacing x with a negative x. So then the last one that we have is if we replace, it's y equals f of x and y equals f inverse of x, which is what? It's an inverse function. So the inverse function can be written as y equals f inverse of x, or it can be written as x equals f of y, because in the inverse we're interchanging the x and the y values. So we've got the graph y equals f of x equals x minus 5 squared. If we write an equation for the inverse, I would replace y with x and x with y. So then how would I solve this equation? How do I get y by itself? Square root both sides. And when I square root the x, I would get a positive and a negative. And then add 5 to each side. So I would write it as 5 plus or minus the square root of x. Now when you go to put this into your graphing calculator, you don't have a plus minus sign. So you have to actually put this as two separate equations. One would be 5 plus root x, and the other one would be 5 minus root x. So when I sketch this graph, I get 4 intersection points. We're going to label them A, B, C, and D. What I would like you to do is I would like you to find the coordinates of those 4 points for me, and then write them down. So it's going to take some time, but it'll make sense in the end why I'm asking you to do this. Okay, so yesterday when we finished class, we started off with this inverse. So graphing a function and then its inverse function. And what I asked you to do yesterday was, although there's only 4 points of the intersection on the graph, only 2 of them were invariant points. So of these 4 points, I asked you to find me the coordinates. So what would be the coordinates of A?
I think it's 2.438 and 6.5.
So 2.43 and 6.56. And what about B? coordinates of B?
3.21 and 3.21.
Okay. And C? Or C, I think, was 3.21, right?
Yeah. Oh, mine are labeled different.
Okay. Then B, that's this point up here.
7.79 and 7.7.
And then D?
6.56 and 2.4.
Okay. Now, let's go back to the definition of an invariant point. What's an invariant point?
A point that doesn't change when reflected.
A point that doesn't change when I reflect it. So when I was doing my reflections in the x and the y axis, when I reflected in the x-axis, the point that was the invariant point was anything that was along the x-axis because the coordinates of y were equal to 0, and when I reflected the 0, it stayed the same. When I did the reflection in the y-axis, it was the coordinates that were along the y-axis that were my invariant points. So of these 4 points, which 2 are the ones that didn't change? Well, think about what happens in an inverse. When I'm taking the inverse, what happens to the x and the y coordinates? They interchange. So if I look at these 4 coordinates, which of these 4 coordinates, when you interchange, are the same?
B and C.
B and C. Now, if I look at the reflection line, when I'm doing an inverse, I've got this reflection line that I reflect over. What do you notice about that reflection line and the invariant points? The invariant points are on the reflection line. And the invariant points were on the reflection line when I reflected on the y-axis and on the x-axis. So that knowledge of that characteristic will help us identify invariant points with a reflection. So if I look at part 2, which I gave you the question on yesterday, it says use a graphing calculator to sketch the first graph and then to sketch the inverse graph. So if I think about some of these points, this point here was at, looks like it's just a little bit past -8. So 0 and -8 is going to become a little bit past -8 and 0. So about right here is where this point is going to change. This point here, which was at 2 and 0, will become 0 and 2. And then if I want to look at this point here as being -1 and 10, it's going to become -10 and -1. So then I get a picture that looks something like that. And again, if I drew that line, that reflection line, so if I draw that reflection line, where the 2 graphs intersected, there's my invariant point. So I get another invariant point along this graph. I think my graph shifted. This was supposed to be here. That was supposed to be kind of there. Stop touching it. So if I mark this invariant point, that's this point of intersection. Where the 2 graphs intersected, that is my invariant point. And if I look at the coordinates of that invariant point, I'll notice that the coordinates, the x and the y, are the same. So the graph, y equals f inverse of x, or sometimes written as x equals f of y. How does this compare to my original function. So it's a reflection in what line? Y equals x. So then if I look at the next one, hello, I'm using my projector.
Oh, can you now?
I am. If I look at part 3, I have this absolute value function again, and I want to sketch the inverse. That's what this notation here means. Sketch x equals f of y means to sketch the inverse. So how I can do that is I can draw my reflection line, which is in that line y equals x, and then I'm going to do a reflection about that line. Or I can take certain coordinates that are on the line and inverse them. So this peak, which was at -1 and 2, would become 2 and -1. And then if I look at my intercepts, I have this one intercept that's at 1 and 0 becomes 0 and 1. So there's one line. So this line here gets reflected that way. And then if I take this point, which was at -3 and 0, would become 0 and -3. There's my next line. And if I look at that graph that I've drawn in green, I ask myself, does it look to be a reflection of the line that I have in black? And except for the fact that my drawing is off because the graph is off, the answer should be yes. So that brings us to the following page, which gives us a summary of these reflections. A reflection is a transformation that reflects or flips a figure above a line. So if we look at the first type of reflection, a reflection in the x-axis. If I'm reflecting things in the x-axis, which coordinates are being impacted? The x ones or the y ones? The y coordinates are what my impact is. So my equation is that y equals negative f of x, because my replacement was replacing y with a negative y. So if the graph of y equals f of x is reflected in the x-axis, then it is the graph of y equals negative f of x. So then if I look at the second one, a reflection in the y-axis, if I do this reflection in the y-axis, which coordinates are being impacted? The x or the y? Which coordinates are being changed when I reflect in the y-axis? The x coordinates. So it's a replacement of x with a negative x. So my equation becomes y equals f of negative x. So I have a reflection in the y-axis, and the graph becomes y equals f of negative x. And then finally, I have a reflection in the line of y equals x. Okay? If I reflect in the line y equals x, what I had is I had a double, or I had two replacements. I replaced my x values with y, and I replaced my y values with x. This is my inverse function. And I can write my inverse function in two ways. I can write it as y equals f inverse of x. That would be this top equation, f inverse of x. Or I could write it as x equals f of y. It's a function of y. And you need to know these notations Because if you're asked a question to determine what x equals f of y is, you need to know that you're being asked to find the inverse of this function. Okay? The notes at the bottom of the page give you what the replacements are, which we've put up with that chart. So we've kind of filled the chart in with the notes that were at the bottom of the page. So now we have some examples to look through. Actually, quite a few examples. So if we look at the first example, you're given these f of x graphs, and you're given coordinates on the graph. There's no way that you could really graph this. I guess you could put it as a plot, and you could put x's and y1, or y1 and then x's, and you could do a stat plot with it, but we want to look at the characteristics of the graph. We don't want to just be relying on the calculator. So if I look at A, I want to draw the graph of y equals negative f of x. What replacement is being made in this equation? Y coordinates. I'm replacing y with a negative y. What type of reflection is that? Reflect in the x-axis. So if I know that information, it helps me to be better able to draw this graph. So I know that if I'm reflecting in the x-axis, anything on the x-axis will stay where it is. Because my y-coordinate was equal to 0, and when I try to flip the 0, I still get a 0, or when I reflect, sorry. So when I reflect this coordinate here of negative 4 and positive 6, it's going to become a negative 6. Negative 2 and 6 becomes negative 2 and negative 6. This one right here, which is 0 and 4, becomes 0 and negative 4. So there's the first part of my graph. And then this 7 and negative 3 becomes 7 and positive 3. And then I take a look, does this graph look like it's been reflected in the x-axis now? Yes. Okay, so I'm going to give you a couple of minutes. I want you to try to do B and C on your own. So if I look at B, what's my replacement? X is replaced with a negative x, and what type of reflection is this? So I reflect in the y-axis. So anything on the y-axis will stay where it is, and everything that's not will basically reflect to the other side. So negative 5 and 0 becomes 5 and 0. Negative 4 and 6 becomes positive 4 and 6. Negative 2 and 6, positive 2 and 6. So now I've got this part of my graph, and then I've got 7 and negative 3 becomes negative 7 and negative 3. Joins to this part here. And then 9 and 0, negative 9 and 0. Does that graph look like it's been reflected in the y-axis? Okay. And then the last one, x equals f of y. What are my replacements? What type of a reflection is this? What's my reflection line this time? Y equals x. So what we can do is we can interchange all of our coordinates. Negative 5 and 0 becomes 0 and negative 5. Negative 4 and 6 becomes 6 and negative 4. Negative 2 and 6 becomes 6 and negative 2. 0 and 4 becomes 4 and 0. We have 7 and negative 3 becomes negative 3 and 7. And then 9 and 0 becomes 0 and 9. So then when I join these points, that's what I get for my graph. And if I draw my reflection line, does it look like I've reflected the graph in that line? Yes. Okay? So class example number 2 gives you graphs. And it tells you that the thick graph is a reflection of the thin graph. So what you have to do is write an equation for each graph. So what you need to determine is you need to determine what is your reflection line. It's either going to be the x-axis, the y-axis, or that mirrored line. So if I look at A, does this graph reflect in the x-axis? Does it reflect in the y-axis? So if it doesn't reflect in those two, it must reflect in the y equals x. And is it reflecting in that way? So then what's my new equation? X equals f of y. Because my replacements is I replaced x with a y, and I replaced y with an x. So in this equation, y becomes x becomes y. Okay, take a look at B. What's my reflection line? The y-axis. So if the y-axis is my reflection line, what's my replacement? X with a negative x. So then the equation of this thick line would be y equals
F of negative x.
good. And then if I look at C, what's my reflection line? The x-axis. So if I reflect over the x-axis, what's my replacement?
Y is replaced with a negative 1.
So then what's my equation?
Y equals negative f of x.
If I went with my replacement, I end up getting negative y equals f of x, so that when I move the negative to the other side, that's how I get the negative in front of the f of x. I want you to do those questions.